Good afternoon. Ask your friends to join. I will be continuing with few more problems on Mohr circle. Shall I start? Shall I start? Okay, let's start. The next problem, solve the, the given problem by analytical method and compare your results by graphical method. That is Mohr circle. Can be a 20 mark problem. The second problem which I am taking is this. The state of stress given to be 80 MPa, 80, 100 compression, 100 compression, X space 50, 50, 50, 50. This is X phase, this is Y phase. Okay. Now in Mohr circle, is given sigma X on X phase is given as sigma 80. This is positive 80. Okay. Tau clockwise 50. Y phase sigma minus 100, tau counterclockwise 50. Okay, let's plot that. Meanwhile, you open the graph sheet. He has given. Okay, one more thing I want to make here. The normal plane is at an angle. This is like this. This is, if I say this is horizontal like this. The normal, it has to be at the center, but you understand that the normal is making some, this is 110 degree from x-axis. This is 110 degree, 110 degree. Therefore, this will be perpendicular. This will be 90, and then this will be this is like this. pivoted. This is x-axis. From here, I am drawing a perpendicular. This is this from this face. This is 110 degree. This is perpendicular is 90 degree. Therefore, this will be 20. This is 90. This angle is 70. 90, 20, 70. Therefore, theta is theta is minus 70. Theta. This is clockwise theta. Theta minus 70. Right? Minus 70. You will give in the problem the uh, uh, the angle made by the normal to normal is the normal is perpendicular to the axis. That is perpendicular. The normal is perpendicular. In case if it gives like this, normal is perpendicular to this plane. Therefore, it is 90 degree, and he has given with respect to this. With respect to this, it has 110 degree. Therefore, this will be 90 degree, 20 degree, and 70 degree. Okay. Okay. Now, he has given sigma x as 80, and then let me write it sigma x as 80, and then on tau phase clockwise 50. If you can see here, sigma x positive 80, clockwise 50. I'll take that point first. Positive 80. This is positive sigma x, negative sigma x, tau clockwise, tau counterclockwise. Positive 80, positive 80 is this point, and then this is clockwise, clockwise 50, clockwise 50 is this point. Okay, this point I will call it as x. This point, let me make a notation. This point I will call it as x. Okay. Next, next, next. Minus 100 and counterclockwise 50 on y phase. Minus 100 minus 100 is this point, minus 100 counterclockwise 50, counterclockwise 50 is this point. Okay, this is your point y. Okay, x phase and y phase. X phase and y phase. Connect these 2 points from x to y. Mark this as this point as center C. Now taking either Cx as the radius or Cy as the radius, from this point draw a circle. Either Cx as the radius or Cy as the radius, draw a circle. Okay. Now wherever this circle meets the horizontal axis, except at the horizontal axis, all the points on the circle is combination of sigma and t, except at this point it is only our normal stress. I will indicate this point as sigma p1. This is sigma p1. This is sigma p2. I will note down the values of sigma. Before that, from I have to calculate theta p1. To measure theta p1, I have to go always from the x-axis. We should not bypass. We should not go from x-axis to theta p2 and then theta p1. No, directly from x-axis. How much I should rotate in order to get theta p1 from the center point. This is for my understanding. For the construction, I'm drawing it. You can directly measure using protractor from x-axis, to this point I have directly measured. This is from this X point to this is the angle. This is my theta P1. Theta P1. This I will call it as, this is my theta P1. Theta P1. Okay. Now I will write. Now I will write what we got. Sigma P1 is equal to around 92 MPa. Sigma P2, which is around equal to minus 112 MPa, right? Minus 112 or minus 114 minus 112 MPa. And then this is the 2 theta P1 is equal to 29.05 degree. Okay, and can anybody make a note of this? Sigma P1, Sigma P2. Sigma P1 is equal to 92 MPa. Sigma P2 is equal to minus 112 MPa. And then 2 theta P1 is equal to 29.05 degree. You have to tell me now. You have to tell me now. Therefore, principal stress sigma P1, which is equal to how much? 92 MPa. Maximum principal stress. This is maximum. Even if you consider if you neglect the magnitude, that is sign, then this will be the minimum principal stress. Generally, this should be the minimum principal stress. Okay. Then if you neglect the sign, then if you consider only the magnitude, this 92 positive in the sense this tension, 92 compression in the sense this is that is minus n in the sense this compression. You can write like that. There is maximum, minimum. Sometimes they will write like that. Minimum principal stress sigma P2, which is equal to minus 112 MPa, 2 theta P1, which is equal to how much? 28 points. How much we got? 29 point something. 29 degree. How I measure theta? You should look for that. How I measure theta? I measure theta in the clockwise sense. Theta from the x-axis. In order to reach sigma P1, I have measured in the clockwise sense. Therefore, theta is negative theta. Clockwise is negative. 2 theta P1, which is equal to minus 29 degree, or theta P1, which is equal to minus 14.5 degree, theta P2, which is equal to theta P1 plus 90 degree, which is equal to minus 14.5 plus 90, which is equal to theta P2, which is equal to 75.5 degree. Okay. Then with the principal stresses, let us go to shear stresses. Shear stress is simple. Shear stress is simple. From the center point, take this line from the center point. This is the center point. Wherever it is meeting, this is the center point where this line is meeting the horizontal. From that, you draw a vertical line from here. Okay, and then on the bottom side also draw a vertical line from the center. Okay, and then measure this. Measure this. Either this or this. This will be your tau max or tau minimum. Okay, indicate this is tau max. Okay, And then in order to get I have told you this is my S1 plane. I have to indicate this is my S1 counterclockwise is positive. This is my S1 plane. This side is my S1 plane. In order to reach this S1 plane, how much I should rotate? uh, in order to reach this S1 plane, how much I should rotate my X phase? How much I should rotate X phase? I'll measure this from here point X, from point X to horizontal sigma phi 1, from point X to this line, this particular line. There is S1 phase. How much I should rotate? This is my this is my this is my 2 theta S1. This is my 2. This is not 2. This is not theta P1. This is 2 theta P1. I have to indicate it as 2 theta P1. Let me indicate that 2 theta P1. This is my 2 theta S1. 2 theta S1. Okay. Now tau max is what 110 in the sense 10 centimeter in the sense 10.2 centimeter in the sense 103 MPa, and then my X phase has to be rotated by 120 degree or 190.05 degree. In the sense it is 120 degree. Okay. Planes of maximum shear stress tau max or min, which is equal to 103.5 MPa. You can indicate plus or minus. That's it. It's at the bottom also and also at the top. This clockwise and anti-clockwise is plus or minus. Okay. And then 2 theta S1, which is equal to how much we got? 119 or 120 degree, right? 120 degree or 119 degree, whatever. 119 point something degree, 119.9 degree, or theta S1, which is equal to, I have to look at the sign how I have rotated. Let me look at that how I have rotated. In order to come to theta S1, how I have rotated my X phase, I have rotated it in clockwise direction only. Therefore this 2 theta S1 is negative 2 theta S1. 2 theta S1 is minus 119.9 degree, or theta S1, let me write it as 60 degree, minus 60 degree. Theta S2, which is equal to theta S1 plus 90 degree, which is equal to minus 60 plus 90, or theta S2, which is equal to 30 degree. You should compare your theoretical result and the analytical results. Okay, and he has given the plane makes an angle of, the plane makes an angle of 70 degree theta. That is theta is equal to minus 70 degree, means clockwise. Since I'm rotating in the clockwise sense, theta is minus 70 degree. So the X phase has to be rotated clockwise, minus in clockwise 70 degree. Okay. This is my X phase. This has to be rotated clock in the clockwise sense by 70 degree. In case of that is X1 way, that is a sketch, it is 70 degree. Where you are writing in the sketch is 70 degree. Whereas when we come to Mohr circle, this is 2 theta. Everything is in terms of 2 theta. Therefore, it has to be 70 degree in the sense 140 degree. I have to rotate it by 140 degree. For that, what I will do for you, you can take the center point and you can directly take 140 degree compass and you can draw a line. But for me, for construction, what I will do, I will draw a line from this point passing to the center. I will draw passing to the center. I will draw a line. Okay, this has passed to the center. Okay, give me a moment. So this point passing to the center, I have drawn a line. From this X point, this line has to be 1 at 140 degree. From this point, this line has to be at an angle of 140 degree. 140 degree. As it passes through the center, okay, okay, okay. This is how we'll get. Okay, this has passed to the center. I have many constraints here. I'll try to zoom and show you. This has passed to the center. Okay, this has passed to the center. I've zoomed it. Okay, let me see where the panel. Give me a moment. Okay, this is next. I have to find from the X phase. I have to rotate it by 140 degree. That is 2 theta, and then I have to measure my. Oh, I have told you. Let me write it. Will come to know. The stresses on the normal and tangential phase sigma normal as similar to sigma x and tau and the normal and tangential there is sigma normal sigma tangential sigma y dash and tau dash which is equal to okay, as similar to sigma x, tau, and sigma y and tau, and the normal and tangential phase, your sigma x dash. That is the other plane which is inclined at some angle we are talking about. What is the normal stress? What is the tangential stress? What is the normal stress on y axis? Normal stress in x axis? We need to find. Now, in order to find that, we'll take a straight line from this point, line vertical, this point. I'll take this point. This is your this point. I'll zoom it later. This point. If I rotate, 140 degree, let me call this. As n phase. N, and this is T face. T, T. Right here. So 140 degree. This is normal face, and this is triangle shape. Okay. Now I have to drop a vertical. I'll show it to you. I'll zoom it and show it to you. Vertical. This point. This point. This is this point. This is sigma y dash and tau dash, and this point is sigma x dash. This point where it is meeting is sigma x dash and tau dash. Sigma x dash from the origin, it's around 28 MPa, and then sigma y dash is around 48 MPa, and then tau dash, if I measure tau dash, whichever axis it takes on the same. 95.6 MPa. Okay, and then this is sigma x dash is 28, and sigma y dash is 48 MPa. Tau dash is 95.6 MPa. Okay, let me write it. And also you should note that sigma n is positive sigma x sigma side, therefore it's a positive 28. This is on the negative sigma side, it's minus 48. Okay, this is 95.6. Sigma n, sigma n, sigma n, here it is, I think. This is sigma n. This is n phase. This is minus 46 and 95.6. This is tau, the sigma t. This is your 28 point something and 95.6 sigma t. Okay, right. Sigma normal minus 46, comma 95.6 MPa, both on MPa. This is positive 28, 95.6 MPa. It's all about your problem. You should find principal stress, principal planes, okay, and then your shear stress, maximum shear plane, the normal stress, and normal planes. Okay, this is how we can do it by using Mohr circle. Next problem, I will discuss another one or two problems, and this entire model will be there for you for the internals. Okay, shall I go on with the second problem? Have you understood this? Have you understood this? Mekala, Abdul Razak, Gurti, have you understood this? Please unmute your mic and tell me, have you understood this?